Here's one more CC2 problem. It's an exponential equation that we want to solve here. So first, I see this negative exponent. I don't like that. So I'm going to rewrite it as a positive exponent. Now remember, when you have a fraction in one of your terms, you can multiply everything by that denominator to cancel out. So 3 to the x times 3 to the x is 3 to the x squared. When I multiply 3 to the x by this term, it'll cancel. Plus 25 equals 10 times 3 to the x. So now I have no negative exponents. I see I've created somewhat of a quadratic expression because I have 3 to the x and I have 3 to the x squared. So I'm going to write this in standard form. 3 to the x squared minus 10 times 3 to the x plus 25 equals 0. So the reason why I'm setting it up in this form is because now I'm setting up standard form for a quadratic. It's easier to see if you do some substitution. I'm going to let u equal 3 to the x to make this problem a little bit simpler. So now I have u squared minus 10u plus 25 equals 0. So now I have a standard quadratic I can factor. Two numbers that multiply to make 25 and add to make negative 10, or negative 5 and negative 5. So you can do your box here. U minus 5 times u minus 5 equals 0. So that means u equals 5 or u equals 5. So u, remember, was 3 to the x. So now to isolate x, I'm going to take the natural log of both sides. You also could have just taken the regular log base 10. The reason why I do this is so now I can use properties of logarithms to bring down that x exponent. X multiplied by ln 3 equals ln of 5. To isolate x, divide by ln 3. It's ln 5 divided by ln 3. Now notice I wait until I have isolated x until I plug in for my decimal approximation. ln 5 divided by ln 3 is approximately 1.46. So keep this in mind. Sometimes we have quadratic exponential equations.